Hello, welcome to my channel CNCR Science and Math Concept. We are doing the question which is based on the topic of semiconductors. The question here is, with the help of circuit diagram, explain full wave rectification using junction diodes. Draw the waveform of input and output voltage. This is for board examination. +2 board examination. This question normally comes in board exam. So first of all, we draw the diagram. This is, first we draw a transformer, a step down transformer. In which we will apply AC. Here is first diode and here is another diode, second diode. And here is load resistance for output. Against this we get output. And this completes the circuit diagram. This is diode D1 and this is diode D2. Now I consider this as point A, this point as B, this point as C and this point as D. Now first of all, what is rectifier? Rectifier is a device which is used to convert AC into DC. So here AC means we will have two inputs, positive half input and negative half input. So here I draw input waveform with time. Here it is voltage. Input is AC, this is positive half, then this is negative half, then again positive half, then again this is positive half of the cycle, this is negative half of input cycle, this is positive half of input cycle, this is negative half of input cycle. Now we'll see the working of full wave rectifier. Accordingly, we will draw output waveform. This will be for output. Now see here. If we say that for positive half of input cycle, if A is negative and B is positive, then C will become positive because here it is mutual induction and in mutual induction opposite polarity is being produced. D will be negative. So now C is positive. So P region of diode D1 is connected with positive. So diode D1 is forward biased. For positive half of input cycle, diode D1 becomes forward biased. When the diode is in forward biased, we get high output. Means from D1 we get high output, but what about D2? D2 is the P region of diode D2 is connected with negative terminal, so it will get reverse bias. D2 is reverse biased, therefore low output. but we get high output from D1. So the current will flow from diode D1 in this direction and we will get high output for positive half of input. So this is high output from D1. Now similarly we now observe for negative half cycle of input. Negative half of input cycle. Now for negative half, A will become positive and B will become negative. Now due to mutual induction, C will become negative and D will become positive. Now as C is negative, therefore P region of D1 diode is connected with negative. So D1 is reverse biased, therefore low output. But D2 is connected, the P region of D2 is connected with positive terminal, therefore D2 is forward biased. D2 is forward biased, therefore we get high output. And what will be the direction of current flowing in the diode? The current will be flowing in this direction. So we can see that it load resistance, current is flowing in the same direction. So high output will also be in the same direction. So for negative half of cycle, we get output, high output in the same direction. This is D2. Again for positive half of input cycle, we will get high output from D1 diode. Then for negative half of input cycle, we will get high output from diode D2. This way, throughout the voltage, direction of voltage becomes in the same direction. When the direction of voltage is in the same direction or the current will also be in the same direction, then we can say that it is now DC. So here we can say that we have converted input AC into DC output. This is how the full wave rectification works with the help of junction diodes, and I have explained how to draw the input and output, voltage output, waveforms also. That is all for this question. Keep watching my other videos for more challenging questions and do subscribe my channel.